Hello class, this is a video tutorial on understanding the gradient as rise over run. So rather than just calculating the gradient using our formula, I'd like for us to try and understand what it actually means. So let's take for example a gradient of n. So n is any number. That means that, well, remember, a whole number is n over 1. Okay. So let's say we begin with a point. If it has a gradient of n, okay, that means if it would have moved 1 unit across, like this, so for every 1 moment that it goes across, it would have risen n amount. So whatever n is. So that's n units up. So the gradient from this point to that point, okay, so that gradient that I just drew there, not these arrows, so from here to here is a gradient of n. So let's take that now with a number. Let's say we have a gradient of 4. Okay. This means, remember, it's 4 over 1. It's a whole number. That means if we begin with a point, let's say here, if we move 1 unit across, so let's say it's 1 centimeter, like this, so it's moved across 1 centimeter, in that time it has moved from here to here, it would have risen 4 centimeters up. I actually don't have enough room for that. Let me just quickly redraw that. Let's quickly redraw that now. So 1 unit across, so from here to there, it would have risen 4 units up. Like there. So these two dots that I'm joining is a gradient of 4 because it has run across 1. And it has risen 4 units up. Okay, let's get one more example. If we have a gradient of -3, once again, it means if we start at a point here, if we move across 1 unit, in this case 1 centimeter, it actually doesn't matter, but for this example we use 1 centimeter. It has risen -3 spaces. So since it is a negative, it's not rising anymore, it's dropping. So it's dropping 3 centimeters downwards to that point there. So these two points have a gradient of -3. So that's, this one's m equals 4, and this one m equals -3. It'll make slightly even more sense if we have gradients that are fractions. So we'll say m is equal to 3 over 5. Okay. Let's say we begin with a point here. Now this time we can clearly see we have a rise over run. So that means for 5 units across, so let's say from here to 5 units across, so it started here and ended here, but in that time it would have risen 3 units upwards. So in actual fact, so that there is 5 across, and this is 3 units up. So it's rise divided by the run, just like that. But this also means that if it had moved 1 space across, so let's say we did get 1 centimeter, and we go upwards like that. This is 1 across. It's 1 space across, and it would have risen 3/5 of a centimeter. So that there would actually be 0.6 centimeters. Let me illustrate that a little bit better. That there's 0.6 because this is 0.6 converted. We'll do one more example. If we have a gradient of m is equal to negative, we'll make it 2/7. So that means if we begin at a point, let's begin there, it will run 7 units across. So let me get 7 units here. That's 7 units. It would have risen 2, well, since it's a negative, it would have risen 2 downwards. So 2 spaces downwards here. So it's those 2 points there. So that there's actually a gradient. That is a gradient of -2/7. That slope there. Not these lines, it's just showing that this is 7 units across. That's a run of 7 and a rise of -2. -2 because it's going downwards. Okay, so I hope that clarifies a little bit more as to why the gradient is rise over run.